Let's go ahead and cover a quick introduction to our next section on linear inequalities and solving problems related to those. Not all relationship between our measurable quantities can be expressed in equations. Sometimes we have minimums and maximums and ranges of values. For example, in your math class, you want to know the minimum grade you can earn on a test in order to keep a B average. And so we can represent this measurable relationship as your grade needs to be greater than or equal to 80%. So we have what's called linear inequalities. Similar to equation, except the equal sign is replaced by one of our four inequality symbols. We have less than, we have less than or equal to, then we have greater than, and or greater than or equal to, our four inequality symbols. So a linear inequality in one variable is an inequality that can be written in the form ax plus b is less than or equal to c. And again, or we could use any inequality symbol. You'll notice it's very similar to our linear equations, which is ax plus b equals c. They function very, very similar, but instead of being equality, we're looking at a range of values that satisfy that given condition. So we have some examples, such as 3x plus 5 is greater than or equal to 4, 2y is less than 0, 3 times the quantity x minus 4 is greater than 5x, or even fraction x divided by 3 is less than or equal to 5. All these are examples of linear equalities in one variable. A solution is any value of the variable that makes the inequality a true statement. And again, this will be more than just one or two numbers. This will be a range of numbers. Our solution sets are often infinite. Solution sets are often infinite in size. Solution sets are often infinite in size. A solution set can be written in a couple different ways. Inequality notation is where we have a simplified inequality where our variable is set to some inequality of a number. In set notation, we take that inequality statement and we define and say that x, all values of x, such that x is greater than 2. Interval notation uses brackets or parentheses to indicate the range of values starting at 2 and going all the way to positive infinity, so increasing forever in the positive direction. And then graphically we can represent on a number line, and so we would start at the given number, such as 2, and we would use one of our graphing symbols to represent whether it's a equal to or not equal to, and then we would shade and draw an arrow in the direction of the solution. So here we have a chart representing comparisons with set notation, graphs, and interval notations. Just note that there's a couple different ways that graphs can be represented. We could use parentheses or brackets at the indicated location, but often we also see open circles and closed circles. And we use open circles when we have the or equal to. So the less than or equal to and greater than or equal to, we'll either use the closed circle notation or the bracket notation, while greater than and less than will use an open circle notation or a parenthesis notation. Anytime we have a range going to infinity, we always use parentheses. We never use brackets when we're looking at the interval, and you'll see that here. Even though we have greater than or equal to, when we're writing the parenthesis on the interval notation, we keep it as a parenthesis on the infinity side, but a bracket on the numerical side. So let's look at a couple inequalities and graph them, write them in interval notation and graph them on a number line. So we have x is greater than or equal to 2. So we're going to start at 2 on our number line. Because it's a greater than symbol, we can use one of two things. We could either use a closed circle because of the or equal to part, or we could use a bracket. We just need to know which direction we're going. Since x needs to be greater than 2, we want all the values that are larger than 2. So we're going to go ahead and shade in. We're going to go ahead and shade in the right-hand side and go off in the positive direction. So we have our point here. Again, the other way that we could graph it using the bracket notation is we could draw a square bracket, again, with an arrow pointing to the right-hand side. So you'll see both notations depending on essentially where the question is coming from, who's the author of the book, anything like that. Now we want to write it in interval notation. So we need to write an interval. We start with the lowest value. In this case, our lowest value is 2. And our graph continues in the positive direction forever without end. And so we use a parentheses on the infinity sign. And because it's the or equal to included, we use a bracket. Next, we have the values of x such that x is less than -1. So we start with -1 on our number line. Because x is less than -1, in interval or on a graph, we could use either a closed circle, and then we would shade everything in one direction. So less than -1 is to the left on the number line. So less than -1 is to the left on the number line. If we wanted to use the bracket notation, we would use a parentheses instead and draw an arrow going to the left. So either notation would be fine. And then we can go ahead and write an interval notation. We want to start with the lowest value. Well, our lowest value all the way to the left is -infinity. So that's where we're going to start, is with -infinity, and then we're going all the way up to the highest value, which in this case is -1. But because it's just a less than, there's no or equal to, we will use a parentheses to close off the side. Here we have a compound inequality. So we have two numbers on a number line that we need. So let's graph a few lines, 0, 1, 2, 3. And looking in interval notation, looking at our graph, we see that x is greater than 0.5. So somewhere here at 0.5, we're going to have an open circle. And we're shading to the right. And then we also have that x is less than or equal to 3. So at 3, we will have a closed circle. And we will shade everything to the left. And this compound inequality is we're going to shade everything that satisfies both parts, everything in the middle. And so we're going to have from 0.5 all the way to 3. And so that will be our solution set. Actually, let me just shade the whole thing in blue. Here and here. So that is our solution set. If we were going to use the bracket notation, we could use a parentheses here and a closed bracket here. The interval, our lowest value is 0.5. Our highest value is 3. Because we don't have the or equal, we use a parentheses on this side. Because we have the or equal, we use a bracket on this side.